Okay, for example 2, guys, to calculate the perimeter of an isosceles triangle, the expression 2s plus b is used, where s represents the length of two congruent sides and b represents the length of the base. What effect, if any, does increasing the length of the congruent sides have on the expression? All right, so what I want to do first is kind of remind you of what an isosceles triangle looks like. It's a triangle that has two sides that are congruent and then a third side that is not. I did draw mine to look a little more equilateral, but the idea being that this would be length S, this would be length S, and then you have your base at the bottom. Okay? So the question here is, what effect, if any, does increasing the length of the sides have on your expression? So we have 2s plus b. First off, if I increase the length of the congruent sides, I'm only dealing with the s sides. So nothing would change about b. Okay, so that's the first thing to note. There will be no change in the base. Okay, so in the example I have, really what we're talking about here is making this triangle taller. Okay, because we're increasing the length of these sides right here. But whatever I do to this one, say for example I added 1 to it, I would also have to do over on this side, because for it to remain an isosceles triangle, those two sides have to remain congruent or equal. Okay, so how would that affect the overall expression? Well, let's just use our example here of adding plus 1. So instead of having two s's, in our new example, I would now have 2 times s plus 1. I'd have 2 of those. Whatever s was, we added 1 to it, just as an example. So if I were to distribute that out, I now have 2s plus 2 plus b. How are these two things different? How are these two things different? This plus 2, right? So we added 2 units of measure, whatever those are. Could be inches, could be feet, whatever's appropriate for a given triangle. But I added 2 of those units. How does that relate to the change that I made on each individual side? I added 1 up there, but in my final expression, added 1 up here in my final expression, I'm adding 2. So basically, whatever I added to one side, it ends up being doubled in the final expression. I wonder if that theory would hold true for another value. So what if, let's draw a new triangle here. What if we did something else to it? What if we tripled it? What if we said we're not going to add something to s, we're actually going to make the length 3 times as big. Again, we can't visualize that, but whatever s was, we're going to make it 3 times as big. All right, so now instead of adding 2, we have 2 times 3s plus b. Because again, we have 2 of those sides. Now it becomes a 6 out front. How is that different from the original? The thing that changed about the sides got doubled in the final expression. The thing that changed about the side up here got doubled in the final expression. Same thing happened down here at the bottom. It was a 3 being multiplied, then it became 6. It got doubled. So because it's happening to 2 sides equally, whatever the effect on one side is gets doubled for your final expression. Now that's a little bit deeper than what the question was originally asking, but I wanted y'all to kind of have that thought process in your mind of, don't just identify generically what's happening, see if you can get specific. Okay? So how did you finally answer this question? So what effect, if any, does increasing the length of the congruent side have on the expression? So there will be a change to the term 2s, but no change to the b term. Okay? I want you to think about that, though. Think about what we're talking about here with this example and the depth we went to over here of trying to get a little bit more specific when you start looking at some of the Walsh stuff for the homework, for the assignments. Okay? And now we're going to move on to example 3.